All right, it is 9:23. I'm not going to re-explain all of that, but notation is important. Okay. Perform the educated operations. All right. So again, notation is everything. You can see that we have our f function here and our g function. And we have this crazy notation, f plus g of 3. So the real question is, what does that notation really tell you to do? Plug what in? It's really f of 3 plus g of 3. That is the, not x3. That is the actual notation. Again, that's the old school way that we would write it. And you know already what f of 3 tells you to do. What does f of 3 tell you to do? Plug 3 in for x. Go to your f function, and in place of x, we're putting in a 3. So we can do that. 2 times a 3 plus the 1. And then what does g of 3 tell you to do?
Plug it in to do that.
Plug the 3 again in place of the x. So that's going to be plus 3 squared plus 2 times 3. And can you multiply all that and add it together? What'd you get? 22, yeah. 6 plus 9 is 15, plus 6 is 21, and 1 is 22. Okay, good. All right, so then what does f minus g of negative 1 really translate to? What does it really mean? F of
negative 1 minus f or g of negative 1?
Yes. F of negative 1 minus g of negative 1. Now, the tricky part here is anytime we are subtracting, we want to make sure that we subtract the entire thing. So, subtraction, if I'm going to test you on something, this is it. Right? Because what mistake are you not going to do? You're not going to distribute, right? So, there you go. That's what I'll get you on. I'm going to get you. Okay. All right. What does f of negative 1 tell you to do? Plug in negative 1. So 2 times negative 1 plus 1. And then I'm going to subtract, a big subtract, and we're going to subtract a whole lot of stuff. And again, g of negative 1 says go to the g function and plug in negative 1. So that'd be negative 1 squared plus 2 times the negative 1. So you guys know how to do this stuff already. And if you were to work this out, then we'd have negative 2 plus 1 minus 1 minus 2. What do you get? 0. Okay, letter C, f over g of x. What does that really mean? F of x divided by g of x. Very good. And so very easily here, this one we don't have a number to plug in. F of x is right there. It's equal to 2x plus 1. So it is just the function f of x divided by the g of x function, which is x squared plus 2x. A lot of times this is a totally wonderful answer. I am always going to encourage you to factor your denominator if you can, because we want to see if we can reduce. What can we take out of the denominator? Take out an x, what's left over? X plus 2, good. And then we have, so nothing reduces here. But the reason I like this form is because it's super easy to see what is x not allowed to equal. 0 and negative 2. So again, that's domain, and denominators are not allowed to be 0. It's always a good thing to be thinking about that. So I like to remind you whenever I can. And then we have fg of x. What does that mean? F times g, f of x times g of x. And again, this is all in terms of x. So it's taking my f function, which is 2x plus 1, and multiplied by the g function, which is x squared plus 2x. And what do we need to do? FOIL, yeah, distribute. Yeah, so first times first would give you 2x cubed. The outside, 4x squared. The inside is 1x squared. And last times last is 2x. So 2x cubed, 4x squared plus 1x squared is 5x squared plus 2x. Okay. So you're going to have a mix today. There's one more thing we're going to talk about, but we are going to have a mix of ones where you have a value to plug in and ones where it's just in terms of x. And that's what this means, in terms of x. Literally, there's terms with x in them. Okay? Jake.
Could we factor it?
Well, if you were to factor it, you'd get right back to here, right? So they probably just want you to go here. Yeah. It's really denominators we want factored. But you'll see, I think you'll see on the worksheet, it'll leave it like this. So, and that's fine. These are equivalent. All right. One more thing we're going to talk about. Okay. All right. If you guys have your book open still, the first four functions that we just did, the add, subtract, multiply, and divide, are called composite functions. Here are a composition of two functions. And you can look on page 85, turn the page. Composition of two functions from page 85 is where we take one function and plug it into another function. It's like a song within a song. So, you know, when you're singing a song and it's comprised, it's got lots of different, the chorus repeats itself over and over again. So that's like the inside the song part, the only part we actually remember, right? And then you've got all the verses. Anyway, sorry. So again, we have the indicated operation. I don't know what happened with PowerPoint, but my notation is all screwy. This
F degree.
F degree, yeah, gee, it's not, yeah, it's not, it should just be down in the middle instead of up high. I don't know why it wouldn't do what I wanted it to. So, you should know that it's a teeny tiny little circle, and it stands for the word of. So this is red, F of G of 3, and that's how you would say that out loud, F of G of 3. If you're looking on page 85 and you see again, this notation is the new school notation that I absolutely hate because it's really quite meaningless. Yeah, so F of G of 3 really means F of, and then inside is G of 3. This is what it really means, F of G of 3. This is the old school notation, and I like this better because of order of operations. We're going to start on the inside here. What does G of 3 tell you to do?
Plug 3 into the G.
Yeah, plug 3 into the G function. G, replace the X with a 3. So we're going to take and plug in. So that's going to be 3 minus 4, which is what? Negative 1. Good. So we are always going to start inside the function and evaluate that first and slowly work our way out. Now we get to do F of negative 1. And what does that tell you to do? Yeah, so go to the F function and replace the X with a negative 1. So that would be negative 1 squared plus 1, which now is 2. Okay, so if you know the notation, this is really quite easy, all right? Again, bad notation. I'm sorry that it did this. This is really g of f of x, as opposed to that, whatever that looks like. G of f of x. What does that really tell you to do? What's on the outside? G. G of, what are we going to put on the inside? F of x is going to be on the inside. We're going to start here. What can I replace f of x with? Yeah, f of x is equal to x squared plus 1. X squared plus 1. Nothing to plug in there. I'm just replacing something with its equivalent. And so now this is telling me, hey, what is this telling me to do? Yeah, go to the g function and replace the x with this whole thing, x squared plus 1. So we're going to go up here, and in place of the x, we're plugging in x squared plus 1, and then minus 4. Do I need these parentheses here? No, not really. So what is it? X squared minus 3. That is g of f. Composition of functions. Today we're just talking mechanics. Tomorrow we get to the hard part, which has to do with domain. Okay, so know that the hard part is coming, but today it's the easy part. Okay?
Thanks. Mondays be tough sometimes.